Welcome to this deep dive into DWM, the Dynamic Window Manager. If you're new to window managers or the concept of tiling window managers, don't worry, I've got you covered. A window manager is a program that controls the placement and appearance of windows within a graphical user interface. Unlike full desktop environments like KDE or GNOME, which come with a suite of integrated applications and tools, window managers are more lightweight and customizable. And one of the most lightweight and minimalist of them is the Dynamic Window Manager, or simply DWM. It is a tiling window manager that organizes windows in a non-overlapping manner. Instead of dragging and resizing windows manually, tiling managers arrange them to fill the screen efficiently, allowing for more productive use of screen space. Most of the window management is done via the keyboard, allowing you to quickly switch between windows and perform other actions without taking your hands off the keyboard, making the user experience significantly more productive. DWM does not have a configuration file in the usual sense. You cannot change something on the fly. For this, you need to change the header file config.h, recompile DWM, and then restart it. This may seem inconvenient, but it is precisely its main advantage, allowing you to directly edit the source code of DWM and apply external patches from users. Now let's move on to the process of installing this window manager. Since its main feature is the direct editing of the source code, we will not install it through a package manager, although that is possible. Instead, we will clone the repository with the DWM code using Git. The file config.h needs to be copied and renamed to config.h. This is the file we will edit to change the appearance and behavior of the window manager. Before launching, I recommend changing the terminal in the config to the one you use and installing dmenu so that DWM becomes actually usable. Now run the commands make and sudo make install. As for starting DWM, there are a few ways to do it. If you don't use a display manager, you can add exec DWM to the .xinitrc file, and if you do use one, you can create a DWM session file with the following content. But in general, I recommend starting DWM not directly, but through a shell script, where you set up the keyboard layout, the wallpaper, and handle other auto-start tasks at the beginning, and then start DWM in a while loop. Thanks to this loop, Windows won't close after updating and restarting DWM. So, here we are in our window manager. The default key combination to launch the terminal is Alt-Shift-Enter. After opening several terminals, you can see that they are all organized in a certain way. The screen is divided into two parts. On the left there is one large window. This part is called Master. And on the right there are all the other small windows. This part is called Stack. The windows use the screen space as efficiently as possible, automatically taking their positions and aligning like tiles. That is why DWM is called Tiling Window Manager. Tiling is the main principle to consider when working with DWM. We will talk about the default hotkeys for managing tiling windows a bit later, but for now, let's move on to configuring DWM. The configuration of this window manager is represented by a header file in C language. But don't worry, you don't need to know C to understand it, as the configuration file is quite intuitive. Let's go through the main elements of this file. The constant border px is responsible for the size of the window border. Snap is the distance in pixels at which windows will snap to the edges of the screen. Show bar controls the visibility of the bar. 0 means hidden and 1 makes it visible. Top bar determines the position of the bar. 0 places it at the bottom, 1 at the top. Fonts is an array of fonts used on the bar. You can specify the size and formatting with a column. You can search for font names on your system using the commands fclist and grep. dmenu font is the font used in dmenu. Next are 5 colors used in the DWM theme. Below there is a table showing where each color is used. The top row shows normal colors, while the bottom row shows the colors of selected elements. FG stands for foreground, meaning text, and PG stands for background. Tags is an array with the names of tags, meaning workspaces. You can specify not only numbers but any symbols here. And this is the table with the rules for windows. Windows can be identified by class, name, or instance. To identify the window, use the xprop utility and the corresponding WM class or WM name values. The first value of WM class is the instance, used to distinguish different instances of the same window class. Tags mask is the tag on which the window will appear by default. Tag numbers are powers of 2, so they are specified by the following formula, where n is the tag you want the windows to appear on. For instance, if I need Chromium to appear on the 6th tag, I write 1, binary shift left, 5. Is floating is a parameter that determines whether the window will be floating, meaning ignoring the tiling layout. And the last one specifies on which monitor the window will appear. -1 stands for the current active monitor. With the rules sorted out, let's move on. Mfact is the ratio by which the screen is divided into master and stack. Nmaster is the number of windows in the master part. Resize hints determines whether DWM will ignore size hints in tiling mode. Size hints are properties set by application windows that specify the minimum and maximum size, as well as the aspect ratio that the window can be resized to. Lock full screen enables forced focus on full screen windows. Layout stands for window placing algorithms. The default DWM has only 3 of them: master and stack, floating, and monocle, where all windows are maximized. Here you can also configure the icon that will be displayed for each layout. The macro mod key defines the default key for controlling the window manager. By default, it's Alt. You can change it to Windows key by replacing mod 1 mask with mod 4 mask. The next macro controls working with tags. Mod key plus numbers switched between tags. Holding Shift moves window between tags. Control unites tags. And Control plus Shift shows a window on multiple tags simultaneously. This macro represents the shcmd function, which runs shell commands. dmenu mount specifies the monitor on which dmenu will be launched. 0 is the first, 1 is the second, and so on. -1 will launch dmenu on the current active monitor. dmenu cmd and term cmd are the commands to launch dmenu and the terminal. And then comes the hotkeys configuration. First, the modifier is specified, then the main key, the function, and the argument. In the description I will leave a link to a cheat sheet with hotkeys. I recommend you open several windows and experiment with hotkeys to understand their main functions. Now let's add volume and brightness control and a screenshot tool to DWM. For screenshots, I prefer to use Flameshot. To launch it, we use the command flameshot GUI. As you may have already noticed, when writing shell commands in DWM, instead of spaces, we specify words as array elements, and at the end of the array, according to the C language rules, there should be null, so that the execvp function, which executes these shell commands, understands where the list of arguments ends. Therefore, the command to launch Flameshot will look something like this. Now in the array with hotkeys, create a new element without the modifier, with the kxkprint, the function spawn, and the argument Flameshot, like this. After recompiling DWM and restarting it, pressing print screen will launch Flameshot. To adjust the volume and brightness, we need to include the header file xf86ksim.h, which adds macros for the keys F1, F2, and so on. However, if you wish, you can assign any other keys for these purposes. Similarly, create new elements in the array without modifiers, specifying our macros. I decided to specify the commands directly in the array, rather than in a separate constant. Next, let's move on to configuring the status bar in the top right corner. You can configure it using the xsetroot command and the name argument. I used to have this shell script, which updates every second to display simple widgets on the bar. But for such purposes, it's much more practical to use a small program called DWM blocks, where each widget updates not every second, but at a specific time, or only with a certain signal. Clone the DWM blocks repository, copy the default config as blocks.h and open it. Here we specify the widget icon, command, update interval, and if necessary, the signal. By sending this signal to DWM blocks, the widget will update. This is useful, for example, for widgets that display the keyboard layout or volume. The keyboard layout, regardless of the key combination you specified in setxkbmap, is perceived by Xorg as ISO next group. Therefore, you can create a hotkey like this to instantly update the layout display via a signal. And to display the same icons on the panel as I have, don't forget to install Font Awesome and add this font to the config. The source code of DWM has less than 3000 lines of code, yet it contains almost all the necessary functionality for a window manager. But if you find something missing, you can apply patches with additional features from users, which are available on the official DWM website. For example, you want all floating windows to appear exactly in the center of the screen. To do this, find the Always Center patch, download the .div file, go to the DWM directory and write patch, >, and the path to the patch. Restart DWM, and now floating windows appear in the center of the screen and not in the corner. When you visit the patches website, you might be overwhelmed by the number of patches available. But don't worry, I've picked the most useful ones for you. Vanity gaps add gaps around windows, and optionally a multitude of new window layouts. Awesome bar makes the DWM bar resemble the one from the Awesome Window Manager, allowing you to easily minimize and close windows. Pair tag makes the window layout unique for each tag. In default DWM, changing the window layout on one tag changes it on all tags. SysTray, as the name suggests, adds a system tray to the panel. No border is a simple patch that removes the window border if only one window is open on a tag. With each new patch added, the likelihood of errors increase, and you may need to patch DWM manually by opening the .rj file and adding lines marked with pluses and removing those marked with minuses. However, there is one DWM build that includes all the patches by default, and all you need to do to activate them is change zeros to ones in the configuration file. This build is called DWM flexipatch. As usual, clone the repository and copy patches.h and rename it to patches.h. Do the same with the config.h file. Now, open two terminals, config.h on the left and patches.h on the right, enable restart seek and seamless restart, so that the window layout is preserved after each restart. And now you can start experimenting by enabling any patches you want. I'll leave a link to an interactive map with all the DWM patches, categorized so you can easily find the ones you need. And while editing patches.h, don't worry about some patches being incompatible, as the developers have thought of everything. When you're done experimenting, you can remove all unnecessary code using flexipatch finalizer. As always, links to all the utilities used will be in the description. The command to clean up code looks something like this. Using the O option, we specify the directory where the final build will be located. Run this command, and now you can upload your build to GitHub. If you're interested, you can also find my own Graph-box themed DWM build on GitHub in the description. So, we've covered the installation, the main principles of configuring DWM, DWM blocks, and approaches to working with patches. Surely many of you by now are wondering, why do all this? You can simply install something like KDE or GNOME, which already has all the necessary functionality and which doesn't need to be recompiled after changing settings. And if you're questioning the practical application of software like DWM, you probably don't fully understand why it was developed. It's clear that DWM was never intended for big audiences, and certainly not for beginners. Its essence lies in creating a custom window manager with your own hands, using the starting potential provided by the default DWM. The samurai has no goal, the samurai has only the path. Likewise, the main goal of configuring DWM is not the end point when everything is conveniently set up, as the interest fades then. Instead, it's the process of configuring and exploring the settings, various utilities, patches, and the DWM source code itself. If this interests you, then this window manager will definitely appeal to you. Welcome to the path of the samurai. Well, that's it for today. Thanks for watching, and don't forget to like, subscribe, leave a comment, and have a great rest of your day.